Dogs, what's poppin'? It's Mr. Allen here. We're about to graph some reciprocal trig functions. We got cosecant and secant in this bad boy with a whole bunch of different transformations here. So going to be loads of fun. I can't wait. Let's get it started. All right. We got y equals 2 cosecant, which is our reciprocal of sine. It's important to identify which reciprocal it goes with because we're going to use the sine graph points to help us lay things out for the cosecant graph. Of theta minus pi over 2 and then minus 1 on the outside. Okay. So our period for this one, since there is no period multiplier in here, our period is going to be 2 pi. Our amplitude, we don't really have an amplitude when it comes to reciprocal functions, okay? Because they never stop going up or stop going down. There's a gap in the middle. We'll think about this amplitude for our sine function, but we should not write it down here as a final answer, right? You will be docked points for that, okay? So there's no real amplitude when it comes to reciprocal functions. How about a phase shift? Looks like it's going to the, sorry, a little smudge there. Looks like it's going to the right by pi over 2. So right pi over 2. And then, let's see here, we got domain, range. We'll deal with that afterwards. We'll get the graph, okay? So I've got this minus 1, and I'm going to lay this thing out maybe in like a neonish marker first, okay? So down 1 here. So that's, actually, we should probably scale this thing first. Hold up. Let's scale. Okay. So no period change, which means we're normal pi over 2, pi, 3 pi over 2, 2 pi, okay? And then, lovely, all right. And then let's see here. We'll go back too. We'll go back pi over 2, negative pi, and this is what, 5 pi over 2? No, yeah, 5 pi over 2. Okay, cool. And then we'll go normal. 1, 2, 3, and 4. Negative 1, negative 2, negative 3, negative 4. Okay. So my midline of the sine function would have been at negative 1. So it'd be going somewhere through here with this neon marker that started out kind of orange from my last write over, it looks like. All right, cool. And then let's plot our points for this sine graph, okay? So the sine graph would normally start on the midline, okay? It would start on the midline at 0, 0 normally, but down 1 now. And we have shifted it to the right pi over 2. So it's going to start here. There's going to be a point right there. Then I'm going to go above the midline. And since it is positive, we will go above the midline. So I'm going above by 2, though. So I'll be up here at positive 1. Then I'd be back on the midline, below the midline by 2, and then back on the midline. Cool. So get into that rhythm here, right? On the midline, above, back to it, below, back to it, above, back to it, below. That's good to get into that kind of rhythm there. It is a pattern, right? It's going to repeat itself, okay? So an important thing here with our cosecant graph or our secant graphs is that they're going to have asymptotes. They are reciprocal functions, okay? When I'm on the midline, right, that's when the output is 0 because it would normally be on my x-axis here. It would equal 0, but we've shifted it down 1. Regardless, though, that's where the function would equal 0. And if I do the reciprocal of 0, now I have something divided by 0. It is undefined. So I'm going to go pink for our final graph here, which will include asymptotes wherever this thing equals 0. So I'm going to have asymptotes here, here, and here. Again, I'm only graphing 1 period of this function. We could continue back this way, but I will stick to just 1 period on this one, okay? Now, I'm going to take those points that are not on the midline, and I essentially make these sort of like a U shape, okay? So it's going to come up like this and up like that. And then this one's going to go down. Sorry, next graph. I'm kind of stepping on your toes there a little bit. Hopefully we don't get in the way too much. Unfortunately, it looks like I put +1. Maybe I'll change that, okay? So we can bring it down a little bit. All right. So there we go. There's our secant graph, all right? Now, domain. Domain and range get a little bit different here on this one, if you will. All right, so when we're writing our domain of this function, or any of these reciprocal functions, we're taking into account the asymptotes, the place where the graph does not exist, right? So here's how we write it. We got x cannot equal, okay? You could say x equals all real numbers except, I'm just going to go with the not equal part to keep it a little more clear, in my opinion. All right, so x can't equal pi over 2, right? It cannot equal pi over 2. I know that for sure. I got an asymptote there. But do I want to put a comma and say 3 pi over 2 and 5 pi over 2 and then more and more and more, right? I'm adding 2 pi over every time. Like, bro, that's going to take forever. I could never get there because this goes on forever and I'd never be able to write all my domain restrictions. So we're going to say plus, and then I'm going by, let's see here, pi over 2 to 3 pi over 2. That's 2 pi over 2, which is pi. 3 pi over 2 to 5 pi over 2. That is, again, 2 pi over 2, which is pi. So I'm just adding pi each time, okay? So plus pi k or k pi or pi n. I've seen a lot of people using pi n lately, where n is some integer, right? We can define all those things too. Some teachers ask you to do that. Some are cool with just this here. I tried to get it above the graph there. It got in the way a little bit. All right, so we've got pi over 2 plus pi times n, where n is any integer, right? It could be 0, which would give me the pi over 2. It could be 1, which would give me the 3 pi over 2. It could be 2, which would give me the 5 pi over 2. It could be -1, which would get me back over here to negative pi over 2, so on and so forth. So there's my domain, all right? Whew. That one takes a little thing. We struggle with that one. That one's definitely kind of tough, so we'll see how it goes on this one here. Next one, range, my range. Well, I got to be below, it looks like we go up to -3 here, right? So I'm going to write this in interval notation. We're going to have -infinity to -3, and I'm going to include that -3, because it is a point on the graph. Then we jump up all the way to 1, including it to positive infinity. Can't include infinity, right? You can never get there. There we go. Nice. That was super dope, you guys. It was super dope. Like it. I love it. It's awesome. It's fantastic. We got a whole other example here. There's a lot of stuff. There's a lot of stuff going on here. All right, so now we got secant, and it's negative, and let's see here. Oh, my God. We got ourselves a period change here. Woo! Putting us through the ringer on this one. I mean, who made this problem? I am going to change this, though, to a -1, so we can just go ahead and, shift down 1 and get out of the way of that graph a little bit right there. I feel like that's going to get in the way. All right. So let's see here. Let's go with, we'll do orange again. So for my period here, I got to take 2 pi, and I got to divide it by 6, which gives me pi over 3. Okay, so now my scaling is jacked up, right? So I'm going to say scale down here. I got to take pi over 3 divided by 4. That's going to give me pi over 12. So that's my scale, okay? Every notch that I have here, I'm going to go pi over 12. So we'll say pi over 12 here. 2 pi over 12 is pi over 6. 3 pi over 12, that's pi over 4. 4 pi over 12 is going to be pi over 3, which is the full period, right? 4 notches, we get our full period, right? So notice again, though, that I did 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. This would be 5 pi over 12. This would be negative pi over 12. Negative 2 pi over 12, which is negative pi over 6. So they usually want you to simplify those things, but you can count. Once you have your scale, it's just 1, 2, 3, 4, always over that denominator of 12. Okay? That's a strategy for scaling things out. I'm going to go by ones again on this. 1, 2, 3, and 4. Then we got -1, -2, -3, and -4. Cool. All right, now, let's see our amplitude. Again, amplitude, it's not something that we would have here with our reciprocal functions. It's usually left on there because they'll be asking you a few different questions, whether they're, your normal sine and cosine, graphs, and then all of a sudden you got your reciprocals, you got tangent and cotangent, which wouldn't have an amplitude either. More on that later. But they will usually leave amplitude in there, and it's up to you to say, nope, doesn't have an amplitude. Phase shift, we're going to go left. Pi over 12. Domain and range, we'll deal with that in a little bit, all right? So here we go. We've moved down, right? We've moved down. So let me get the yellow going here, and then we'll do the pink again for like our official graph. So we're going down 1. That's our midline of what would be a cosine graph, right? So now let's plot our cosine points, okay? So cosine would normally be above that midline, right? But we shifted to the left 1, and it was reflected down at -2. Okay, let's double check that, right? So again, the 6 here has already been taken care of in our scaling, so we don't have to worry about that. I normally would start a cosine graph above my midline, right? So here's my midline here. I'd normally start 1 above, right? I have shifted it to the left pi over 12, and we have the negative out in front, which brings me down here. Cool. Cool. So now I'm going to go back up to the midline. Then I'll go above the midline. Then I will, whoa, that's too far. That's too far. Almost messed that up. Classic. Okay. I got to go one above the midline. Then back to it. Then below it. And that's one full period right there, right? We've got from negative pi over 12 to pi over 4, which is 3 pi over 12. That's a span of 4 pi over 12, which is pi over 3. Oh my goodness. If you don't like fractions, you just did not like that much at all. Okay. So we got our layout here. Yes. So I know I'm going to have an asymptote right here where we're on the midline, because if I'm on the midline, this part right here is 0. And when I do the reciprocal, sorry, this part right here would be 0. And when I do the reciprocal of 0, I'm going to get undefined. Okay. So there's an asymptote there. I know we're at -1. It's not actually the value of 0, but when we reciprocal things, it is 0. Let's flip it. Here we got another asymptote. Another one would occur, over here. Another one would occur over here. We're just doing one period. So for this, it's going to be swooping up. You notice they look basically the same. They're just in a different spot. Kind of like how sine and cosine look the same. They're just shifted from one another, right? So there we go. Beautiful. That's one full period. If you were to continue this on, with maybe a different color here, I don't want to get too crazy with it, but like our graph, the asymptotes would continue over here. They'd continue right here. And you'd have this graph that would do this, come down here. You'd have another one right over here. It'd be, wee, woo. These things just go on forever, man. All right, but the stuff in the pink there, that is one full period. From here to here is pi over 3, so that's one full thing, and then it repeats itself. All right, because if I'm going from here to here, this right here is the same as this chunk right here. It's repeating itself. It's a periodic function. It periodically repeats itself. There we go, man. All right, tons of reciprocal fun. Let's take a bit. So you got to get it all together. You got to use the... what you know about sine and cosine. And I just realized I did not do my domain and range. Let's do that because I feel like that's a confusing thing. I'm going to do it in pink so it stands out a little more. Domain. All right. Domain is that x cannot equal. Well, the first one here is just 0. I don't really need to say that if I'm going to add, right? And here this is pi over 6. If I can still see it, yes, it was pi over 6. So we're going to just do x cannot equal pi over 6 n. So if I plugged in 0 for n, I'd get 0. If I plugged in pi or 1, I get pi over 6. If I plugged in 2, I get 2 pi over 6, which is pi over 3. -1 would give me this guy right here, so on and so forth. So it walks itself along that thing, gives you each spot. Range. All right, so for range, I'm going to be, oh boy, I don't leave myself too much room here. I got from negative infinity up to -2, and then from 0 to infinity. So we got, let's see if we can do this. Negative infinity to -2, bracket, union, bracket, 0 to infinity. Sorry, guys. It's kind of scrunched in there. I feel like I need like a larger light board. Maybe I'll make a bigger one. Okay, this guy's only a few feet wide. But maybe a bigger one, more math, more awesomeness. That'd be pretty dope. Maybe I will. We'll see. We'll figure it out. But anyways, hope you guys enjoyed it. Loved it. I loved it. It was awesome. It was fantastic. Have a great day.